At the end of this video, I'm going to have a little section on the poll I put out, the results of that poll, and the impact on how this channel will be structured moving forward. After my last video, where we went through a little bit of a bird's eye view of a network, there was a great deal of interest in moving forward with some deeper conversations. As I was pondering the best way to get into this, I realized that there are some foundational topics that we need to cover before we can move forward. In today's video, we're going to be discussing the OSI model. Now, in the 60s and 70s, when networking was kind of being formulated and solidified, the community was small enough that everyone could basically email one another and figure out how they were going to do things. By the early 80s, things had moved on and progressed. There was a much larger community involved worldwide. It very quickly became obvious that with the language differences, the differences in the methodologies that have been used, there had to be a definition of the different functions of a network. And there were two propositions for this. The one that was chosen as the foundation was the OSI model, and that is still what we use today. The OSI model in 1983-84 was 7 layers, and it was to cover communication from the very most fundamental all the way up to how networking happened within a host, from the cables used to how one process talks to another process. The first layers on the model, and we're going to be building bottom up here. So the first layers on the model are called the media layers. And these layers are really covering anything that happens outside of a computer and the port on that computer that communicates with that outside world. What we call layer 1 is really the bit streaming layer. So it's the electrical or optical signal that is sent out of the port on the device and received by a specific port on a remote device. You'll also hear that referred to as line coding or links, right? These are the for the vast majority of cases, unless you're talking cell or Wi-Fi, which is a whole kind of different world. It uses the OSI model, but it has slightly different definitions for each layer when you get into RF. That is the foundational piece, right? There is no networking if the computer is not connected to something else. The next step up is what's called the data link layer. And this layer operates by using frames to encapsulate the data. So you'll get a header and a footer on the frame that defines everything inside of the data part of the frame is the content, right? It's what we're trying to transmit from this computer to its destination. The framing is what dictates how that information is transmitted. Data link layer includes things like Ethernet. The data link layer is how one computer would send data out to the internet. It can't just send that data out, right? It has to get that data to your cable provider's router or to your cable modem or whatever that device is, that gateway out. So in your network at home, you have a layer 2 network. On that layer 2 network, any device can talk to any device. And we'll get into more detail about this later. The next layer up, which is kind of the last of the networking layers, of the media layers, is the network layer. This is where I've spent my career. What the network layer does is once you reach the edge of that layer 2 network, the network layer takes over from there. And when a frame reaches a router, it is unencapsulated, so the frame is taken off, and what is exposed in the modern world is the IP packet. That header and that encapsulation of the IP packet then directs that that gateway or that device that provides you the next step with the information it needs to move that packet forward. The network layer is really the first layer where we get into just levels and levels and levels of complexity, right? You have access control, you have rate limiting, you have route control, IGPs for routing locally and BGP for routing between networks. It gets very complex at the network layer because this is the layer where the internet is created, right? This is how it's the internet and not just a network, because you're exchanging that data at the IP layer. The next layer up is the transport layer. Now, this is a bit of a gray area because what you get into in the transport layer is where that handoff from a network device, a switch, a router, a modem, whatever, to the host that is actually either sending or receiving the data. This is what we call TCP. And it can also be UDP. There are a bunch of other protocols that exist in this layer that are really all they're designed to do is ensure that the data that is sent is received and recognized properly by the remote host. Now, in the case of TCP, that means that it's a protected path. So if a TCP packet is lost, there's a whole metric in TCP for it to signal for a resend of that packet. It will not allow intermittent drops within it to go uncorrected. There's a lot of overhead that comes with that. And the main difference between TCP and UDP is that UDP is just a data stream. If you drop a packet, everything just moves on and ignores it. And eventually, if you drop enough packets, the connection will get reset or whatever. That's for things like WebEx, Zoom. A lot of that data can be sent in UDP. The one comment I'll make there is that there's this whole packet ordering thing. So it's possible in a network for packets to arrive at the destination out of order. So the source sends 2 packets, 1, 2, and then the destination receives those packets 2, 1 in that order. Part of this transport layer is to, number one, manage that ordering and then either correct it or not, or drop the out of order packets. This is where you get into quality a lot with phone calls, with live video, and we'll spend more time on that later. The reason that's kind of a half and half and a gray zone is because all of the TCP and UDP are host-to-host protocols, but they are key in how the network operates. So layer 3 has to understand some aspect of layer 4 if it's going to do its job properly. Next, you get the session layer, and that is really within the host. Okay, so the transport packets arrive at the host. Any retransmissions, any ordering, anything gets addressed within that, and then it gets handed to the session layer. And the session layer is how that traffic gets basically from the networking side of the operating system. So from your Ethernet port or your Wi-Fi port on your router, that's how it gets transmitted into really the core software development side, the user application side or the service side. Once it's handed off, then you're at the presentation layer. And this is the layer where a lot of client-side work happens. For instance, this is where you would encrypt the data. So before it is even handed out of the application through the OS to the network interface, it would be encrypted or compressed or whatever kind of massaging needs to happen to that data once it's received before it's sent for the network to send it. And then the highest layer is the application layer. Now, we'll get into this a little bit more in the future, but the application layer is really the interconnect point. There's some oddness to this graph you're looking at, or to this chart you're looking at. There's a gap, and it doesn't start at the bottom. The OSI model is about, I don't know, 40 years old at this point, and it's a miracle that it's been so awesome at defining all of this for so long. But there are some gaps. And one of them, which is what we shorthand call layer zero, is really important to understand when you're talking to people like me, because if we use these shorthands, it's because there's maybe not a complex subject, but something that's not accounted for in the original model. Layer zero, when you're talking to networking people or to optical people, long haul people, that means the actual physical thing that is connecting the two ports. Layer one on the OSI model is technically the stream of bits that goes in and out. That's how the electrical or optical signal is sent. It kind of bundled together the assumption that it would have something to send that over. That actually became kind of a gap for us, because what happens if someone cuts the fiber, right? It's not that there's a layer one problem, because both sides are transmitting their data successfully, right? That bit stream is going out. The other side is just not receiving it. There is a fundamental breakdown between those two devices in the physical media that is being used. We call that a layer zero failure. The other one is layer 2.5. There's a design in layer 3 that allows it to perform much better. It requires a whole ton of things that didn't exist in 1984. Effectively, we're creating this wedge where there's something that's sort of like layer 2, but does a function of layer 3 that is not accounted for in the model. I want to make it clear here that the OSI model is the de facto standard for communication. That does not mean that every technology we have on the internet today and computing today fits into the OSI model. It is common in the industry to use these as generalizations, but that's rarely ever enough for someone to understand or make a distinction about something, right? It, like in an operations center, you'll constantly hear people talking, and they'll be going, well, what's the problem? And they'll respond with, oh, it's a layer 2, it's a layer 3, it's a layer 1. And they're not trying to define the problem to the person. They're trying to give them the scope, right? i.e., I'm a routing guy. I've looked at this problem. It's not a layer 3 problem. It looks like what I'm seeing here is a layer 1 problem. There's actually a physical problem with the transmission of the data. Or there's a layer 2 problem. I'm not getting the right encoding on the interface. And that's a way to say, okay, what resources do I need? I need someone to talk to who knows that section of this network. I can only assume that it's something similar on the host layer side and the application side, but there are better people such as Kevin who probably will be able to speak more effectively to how the handoff happens between the software and the network layers. Okay, so that's the OSI model. I tried to be as quick as I could and keep it very high level. Okay, so let's talk about the poll for a minute. I really appreciate you guys all giving your input, and there were some fantastic suggestions in there. And in fact, I'm going to take them. I will keep this content here on the channel. What I'm going to do is set up, and you're seeing this today because this video will be the first one that's on the foundations playlist, or I'm actually doing it as a podcast. And the only reason I'm doing it as a podcast, so it allows me to control the ordering better. The other thing I'm going to do to draw this out is I am not going to do the standard YouTube bling thumbnails on these. I'm going to do a very obvious thumbnail, and you saw the first iteration of that with this presentation. So at a glance, anyone will know if the content is really geared towards, Star Citizen, or, talking about something with Star Citizen. It will have that more Star Citizen-y kind of trying to catch the eye of the watch page. thumbnail. If it's this fundamentals or if it's more networking content, it will have a very sedate, very obvious thumbnail so that all of you can make that decision for yourself as to whether this is worth your time or not. Well, I think that wraps it up. Please leave comments. I really want feedback. If you're new here, like and subscribe if you want more of the two types of contents we're going to be discussing. And with that, I look forward to seeing you in the next video.